Your light bulb isn't inefficient, it's just honest about physics. We spent decades calling incandescent bulbs wasteful. Spoiler alert, they're not broken, they're just following the rules. 1972, the energy crisis hits. Suddenly, 90% of your electricity turns into heat. Engineers panic, we call it waste. But thermodynamics doesn't care about your utility bill. It only cares about entropy. Enter blackbody radiation. Any object above absolute zero emits photons. Heat it up and the spectrum shifts. You want visible light? You have to cook the filament to roughly 2,500 Kelvin. That's not a design flaw. That's just Planck's law demanding a toll. Here's the bottleneck. You can't pick and choose wavelengths like a streaming playlist. The filament radiates everything. Infrared, ultraviolet, and just enough visible glow to read your paperback. You want narrowband light. You need quantum wells. But in 1950, we didn't have semiconductors. We had tungsten and stubbornness. So that 90% heat, it's the exhaust pipe of the visible spectrum. You can't have the peak without the tail. Thermodynamic efficiency isn't about zero heat. It's about maximizing entropy export. The bulb isn't leaking energy. It's doing its job. Then came the light-emitting diode. 1962. Gallium arsenide. You finally got narrowband photons without cooking a metal wire. LED efficacy hits 200 lumens per watt. You tech snobs love it. But don't pretend it's magic. It's just a different bottleneck. LEDs still waste heat. Non-radiative recombination. Substrate thermal resistance. You think your driver board stays cool. It's sweating. The thermodynamic tax never disappears. It just moves from the filament to the phosphor coating. Same law, different packaging. I miss the incandescent, not because I hate progress, because I love the transparency. You flip a switch. Electrons collide, atoms vibrate, photons escape. No firmware updates, no smart home latency, just raw, unfiltered joule heating. It's engineering with no hiding place. We trade blackbody warmth for spectral precision. LEDs give you correlated color temperature on a dial. Incandescents give you a continuous spectrum that doesn't make your plants look like they're in a crime scene. You want efficiency? Fine. But don't pretend narrowband is objectively superior. It's just a different compromise. Let's address the comment section before it starts. Yes, LEDs win on lumens per watt, but you're treating thermodynamics like a skill issue. You can't cheat the second law. You can only route the waste. Calling incandescents obsolete is like calling a mechanical watch inefficient because it doesn't sync to GPS. Weak design choice. Here's the beautiful part. Heat isn't the enemy. It's the proof that energy moved. Every photon you see was bought with thermal friction. The bulb isn't failing physics, it's performing it. And honestly, I'd rather watch a filament burn out than debug a flickering smart bulb at 2 in the morning. So next time you flip a switch, remember, you're not wasting electricity. You're negotiating with entropy. Drop your stance below. Are you team continuous spectrum or are you team quantum efficiency? And please stop calling heat waste. It's just physics keeping score.